Our last example, we're taking a look at comparing an arithmetic sequence to a geometric sequence, or actually series, because we're going to be adding up our terms. So take a guess, which do you think is a better deal? If you save $100 every day for 30 days, or if you save a penny the first day and you double the amount that you save each day for 30 days. So we're going to start by looking at the arithmetic series. First 5 terms in the sequence, we save $100 the first day, $100 the second day, $100 the third day, and so on. To write the recursive formula, remember this is the one where we have t sub 1, we explicitly state the first term, and then we write the next term in terms of the previous term, plus the common difference. Well, in this case, the common difference is 0. We're not adding anything to each of our terms. So t sub n equals t sub n minus 1, meaning the third term, for example, equals the second term. The explicit formula, t sub n equals our first term, plus the common difference times n minus 1, but of course 0 times n minus 1 will be 0. Any term in our sequence is 100. We're saving $100 each day. So the sum formula for an arithmetic series is n, number of terms, times the quantity first term plus last term, all over 2. We can substitute that in, but we're going to answer that question on part F. To write the series in sigma notation, we put k equals 1 at the bottom. We want to start at the first term. We're summing for 30 days, and our explicit formula is 100. So what this says is add 100 30 times. So we can do that. How much money did we save? 30 times 100 is $3,000, which is a nice chunk of change after 30 days. So let's take a look at this geometric series. Really doesn't look very promising, saving a penny, 2 pennies, 4 pennies. You don't have a whole lot of money even after a week. So the first 5 terms, we've got a penny, 2 pennies, 4 pennies, and so on. The recursive formula, again, we write this in terms of the previous term, so we explicitly state that first term, and then the nth term is in terms of the previous term. So our common ratio is 2, we're doubling our money, 2 times the previous term. The explicit formula for the geometric series sequence, keep saying those backwards, is the first term times the common ratio to the n minus 1 power. So the sum formula, that's the one that we looked at today. The sum of the first n terms is the first term times 1 minus the common ratio to the nth power, all over 1 minus the common ratio. So we can make this a little bit more explicit. Again, we're going to find the sum in a minute. The first term times 1 minus our common ratio to the 30th power over 1 minus our common ratio. And we'll evaluate that after we answer a few more questions. So the sigma notation, same thing for the arithmetic sequence, sigma notation series. We start with the first term, we're going to the 30th term, and we put the explicit formula as what we're taking the sum of. How much money did we save on day 10 alone? So now we have to go back to our explicit formula. The 10th term is the first term times 2 to the n minus 1 power, or 2 to the 9th power. Which sounds like we might be getting some pretty big money here, 2 to the 9th power times a penny. Nope, $5.12. So day 10, we still only are saving $5.12. So it's looking pretty good for this arithmetic series for $3,000. How much money did we save throughout the month? So let's evaluate that formula we just came up with for our sum. That should be 30 equals the first term times 1 minus the common ratio to the nth power, all over 1 minus the common ratio. We ended up saving $737,418.23. So this is the power of compounding your money. Now you're never going to find a bank or an investment where you earn double on your money. However, this shows you that if you can find a good interest rate, much better to take advantage of that. And here are your U-try questions.